Hello, everybody. My name is Michael Merrington. I am the General Manager of IndEx. We are a part of the XWorks group. We're a group of 10 companies that concentrates on everything to do with hazardous areas, hazardous locations, from non-electrical and electrical. So I'll be turning off the webcam at this time, and we shall start the presentation. Thank you for attending. Okay. Welcome to IndEx webinar number 11, EXQ, protection by powder filling. So let's jump into it. What is EXQ about? Well, ignition capable materials are fixed in a position and completely surrounded by a filling material to prevent the ignition of an external explosive gas atmosphere. How does it do it? Well, it quenches, extinguishing a flame. Doesn't stop all flames, but it certainly extinguishes it immediately. Now, the protections via filling method. Now, when they say powder, it can be a solid quartz, so think of sand, or solid glass particles. So what applications? Well, they may be for electronic circuits, transformers, fuses, relays, intrinsically safe electrical apparatus, associated electrical apparatus, and switches. But they will always be equal to or less than 16 amps, less than or equal to 1,000 volts, and less than or equal to 1,000 watts. So there are limitations. So if we ask, sorry for the spelling mistake, how does EXQ prevent ignition? Give another 10 seconds. Okay, so the answer is quenching. It basically strangles off, because of the tight little distances between the sand or the powder or the quartz. There's not sufficient oxygen in there. It quenches the flames, okay? So what are some important constructional requirements? Well, there's two different types of EXQ seals. Permanently sealed, or those intended to be open for repairs. The permanently sealed ones have to have visible evidence if it has been opened. Usually, they'll use something either via welding, soldering, cementing, or rivets, meaning if somebody opens it, you will see the damages. Now, also, it shall be marked, this container has been permanently sealed and cannot be repaired. Those intended to be opened for repairs shall be designed where they are not damaged when repaired, refilled, and resealed. And it shall be marked, this container is factory sealed. Consult manufacturer's instructions for repairs, IOMs, installation, operations, and maintenance manuals. Now for pressure test, well, you would refer to the further standard. So right now we are referring to IEC 6007579-5. So other construction requirements. Well, the filling material shall be in accordance with this ISO standard for how the dry materials and the size of it. So we're talking 1 millimeter or 500 micro. Yeah. Now, documents shall be prepared that includes the specifications of the particle materials, size ranges, as well as the filling process and measuring taking to ensure proper filling. Then there's tests of the dielectric strength of this material. There's specific things involving filling procedures. Now, voids are unwanted spaces. So they usually shake the container to ensure it spreads equally. Free spaces, which are designed free spaces, shall also have the filling materials. Now, the reason I keep emphasizing the word containers and not enclosure is containers are not external enclosures. So you'll not find an EXQ enclosure. It would be an EXQ. See what I mean? The container of the EXQ equipment is installed or intended to be installed internally to another enclosure, is contained within the same as that of an EX component. So usually the EXQ device is a container which goes into an enclosure. So distances through materials. Well, that kind of comes down to creepage and clearance distances. Yeah. Except where specified, the minimum distance between the filling materials between electrically conducting parts of the equipment shall follow table 1. This does not apply to conductors used for field wiring connections which penetrate the wall of the container. So creepage and clearance distances. Creepage over the surface, clearance, straight line over. Now, let's show an example. What we have here is a handheld computer. This Bartek handheld computer is actually, we will look on the label, it shows EXQ bracket ID. So it's powder filled protected and also intrinsically safe for zone 1s. So what is the EXQ components? Well, when it's been opened up, inside there's further construction which contains the sand. See all the particles that have fallen out? Now, also look at the label where it says this enclosure is factory sealed. On the past documents, the word enclosure has been striked out. So this is an older version of a piece of equipment. But it says it's factory sealed, do not open. There's an example of that this is an enclosed, not to be opened container. Now, if we go to the IECEx website and actually search via IECEx PTB 1343X, we look at different issues of certificates. Which one do we choose? Well, the manufacture date indicates August 2015. So we have two different dates. August 8th, 2015, but we don't know the exact date of manufacture on this. So do we refer to issue 1 or 0? Well, it's interesting. What you can do is go to the latest certificate and see what it says down in the certificate's detail of changes. And what it said was including the updates to the standard of 60079-5 2015. Inclusions of other tests, adaptation of marking. So if I were a betting man, and this was August 2015, and the standard came out before that, but the certificate says that the marking had been updating, but it still says enclosure instead of container, I would say that we would be referring to issue 0. This was manufactured before the issuance of the new certificate or before the manufacturer had time to comply with the new certificate wholly. So when you go further into the certificate and actually look at the marking information, when you do an inspection, when you are a design engineer, you do not order a piece of equipment and only look at the certificate and say that everything's good to go, or you do not just look at the EX data plate sticker in the field. No, you don't do that. You compare the certificate, the correct issue, with the data plate in the field. So if we look at it, it says EXQ bracket IB 2C T4GB. So when we look at these lines below, it would seem to indicate that it could be this line or this line. So if we look at the model number, you can then compare and find out which one that it is. So like we said, either that one or that one. All information can be found on the IECEx website. Surely the handheld device is the enclosure and the container is the components inside. Well, with the new standard, it would be interesting to see what the new label says. When in doubt, refer to the certificate. So, once again, distances through the filling materials. When it comes to the distances between the filling materials, you follow this figure, figure 1. It's a little in depth. We'll go past. Now, connections. So if we're looking at this device here, certainly none of these enclosures are EXQ, but the EXQ container would be inside, probably a fuse, a little transformer, something electronic. Now, connections for equipment. Cables used for entry into electrical equipment with EXQ shall be an integral part of the equipment and shall be protected and sealed as specified. So what that means is if you do have a EXQ piece of equipment that is not an internal component, but is the actual equipment itself, the cable shall be integral, meaning it shall come with the equipment. So it shall enter a gland that is permanently sealed with the piece of equipment. Now, EX component types, EXQ, shall comply with the termination facilities that it's used in. Usually EXQ is used in an EXE junction box, or let's say an EXE fluorescent light, or that GRP box. So the terminals would be EXE. So once again, it could also be used for capacitors, cells and batteries, and they have their own limitations. Capacity of less than 1.5 amp hours and other things. So what's one of the main considerations when it comes to EXQ? Well, temperature limitations under fault conditions for the fuses, malfunction exclusions, the protective devices for temperature limitation, and the power supply prospective short circuit current. So what are we looking at? We're trying to reduce the ignition source, the heat, or arcing and sparking. And once again, it makes reference to creepage and clearance distances. So if we look at a fluorescent light, what could be EXQ on this device? Certainly the starter, even the transformer could be. They could be EXM or Q, but their terminations would probably be EXE. So if we ask you a question, this one may seem a little bit out of place, but if you watched the previous webinars, you should know the answer. Is IP67 rated for IP55? This has two possible answers. The percentages are looking much better than past instances. And we'll close that. Okay, so the correct answer is IP67. So the 7 for liquids does not give you 5 or 6. So IP67 does not give you IP55. The answer would be no, or it must be IP55/67. If you're unsure, please watch webinar 4 or 5. Somebody made comment that the 1000 volt rating max on this table, it goes up to 10,000. People still make mistakes on standards. So just be aware that might be a common table that is shared amongst many of the IEC 60079 standards. That's probably why that is. Now, what are testing requirements? Well, there are type testing and tests such as a pressure test of the container. They have to do sample tests as per the 60079-0, and the container has to be tested at 50 kilopascals over pressure. It shall not deform and shall not exceed 0.5 millimeters in any direction, meaning the body of the device could shrink or expand in any direction, anywhere on its surfaces, as long as it's not more than 0.5 millimeters. And this test happens for 10 seconds. Now, containers without breathing or degassing openings will be tested at 1.5 MPa. So a significant increase in pressure for 10 seconds. But it must be without capacitors that are plastic foil, paper, or ceramic, because they would be damaged. And the volume of the filling material is 10 times lower than the volume of the capacitors. So when we get into IP ratings, the testing requirements are as per 5.12, but you actually refer back to the constructional requirements. Now, the minimum IP rating is IP54. Generally, you're not going to find too many IP54 EXQ devices, unless they're internal. An internal container, such as the ones within a fluorescent light. But if it is IP55 or greater, and the container is not hermetically sealed, so hermetically sealed, prevention of it leaking, okay? So if it's not hermetically sealed, It must have a breathing device, and the container must be IP54. Another exception is, for use in a clean, dry room, IP43 is acceptable, but a certificate with X listing the conditions of use is required. This is one that most would not see. It will be for specific applications, rare applications. Now, the EX components inside of enclosures also have to be minimum IP54. Would they be IP66? Maybe, but the manufacturer really doesn't need to do that. The outside enclosure would be the greater IP protection, perhaps. But for this testing, the container must be destroyed to review the results. Why? You need to see if the sand, the quartz, got wet. Now, the maximum gap shall be between powder, I should say powder, shall be at least 1.1 millimeters smaller than the smallest dimension of the filling material. So whatever the size of the material is, the gaps shall be at least 0.1 millimeters smaller than that dimension. So if the filling material was 1 millimeter, then it would have to be 0.9 millimeter for the maximum gap between each of those grains of sand or glass. Well, we talked about dielectric strength testing. Basically, it's a 24-hour test at 1,000 volts. There's that 1,000 volts again. Maximum temperatures, there's many different considerations. Three different considerations. We're not going to go into too much detail on that, though. So if we ask you a question, what are the signs of failure of an EXQ device? Now, you would do this during a detailed inspection. Multiple answers here. So perhaps on some of your past EX competency courses, people only glanced over EXQ for you. We're now giving practical real world consideration. If you were doing the inspection, what would be obvious signs of damage? Remember, detailed inspection. So you could be using multimeters. You could be visually looking at things, and you could be removing it to have a better look at it. Give another 10 seconds. Okay, so the correct answer is all of them. When looking for damages on EXQ equipment, you're not going to open it to look at the sand. The repair would be done at a repair shop or at the manufacturer. What you would be looking for is discoloration. That would indicate overheating or arcing and sparking. You would use a multimeter, measure the resistance. If the resistance was abnormally high, could be a problem. Distortion. Well, we talked about distortion before, where if the enclosure moves more than 0.5 millimeters during testing, we don't want any distortion. So distortion would also fall under melting. Once again, it'd be overheating. And if we had an open circuit, if it was not designed to be open circuit, that would indicate a break in the internal conductors. So these are all important considerations when inspecting EXQ. From my own experiences, I've seen people just glance at it and say that it's okay. You need to have a good look at it. You need to look at all sides. Look for obvious damage. So, what other routine tests are done? Well, there's pressure tests of the container. And they're based off of batch numbers for up to 100, 101 to 1000, 1001 up to 10,000, and batches above 10,000. And usually they're tested at 1.5 times routine test pressure. Okay. Now, the dielectric strength test. Well, when you look at this figure, they have two electrodes that are insulated. And what they do is they have this in a container, and they pour the filling material in there. And then they measure the resistance, and do a dielectric strength test between those two. So that's how they confirm that the creepage and clearance distances are sufficient. When doing this test, they make sure that there's at least 10 millimeters of filling materials on all sides. So if we show you a real world application of EXQ, some of you might not know what this is, but this is a water treatment plant. These devices right here are flow meters. Part of their construction for this specific model is EXQ. So internally, they have EXQ components. So it's probably an EXD and Q. And this one might be intrinsically safe as well. So somebody asked the question, when or why would you design a device or equipment to be EXQ instead of an other EX protection technique? Well, if we go back to the computer, the reason they went with that is because intrinsically safe is a difficult to comply with concept and standard. So the screen is EXIB, but EXI has nothing to do with the constructional requirements of the enclosure of the device. So instead of making it EXD or overbuilding it, now this is an older device. So they decided to go with EXQ and put the grains of sand, let's say, in there. Just another protection technique. It allows for flexibility of manufacturers to produce new devices for the marketplace. So, what are marking requirements of EXQ? Well, they all have to be marked as per this standard and 60079-0 general requirements. Whether they're permanently sealed or factory sealed, and you have to consult the manufacturer for repair. Each connection facility for external connections shall be marked and identified with their rated voltage and current. Any external fuse data, if the type of protection depends on the use of such a fuse, such as required external fuse, the short circuit capacity, and optionally permitted prospective short circuit current. So it's very important because of heat considerations. Any of these markings may be replaced by technically equivalent information. If you're a manufacturer, it's much easier if you comply with this standard than it is to use your own words sometimes, because people may misinterpret what you say. If something is as per the standard, this is verified and validated information. Now, what's changed in the instructions? Well, the instructions prepared in accordance with the general requirements of 60079-0 shall also include, where listed by the manufacturer, the details of the refilling, resealing, retesting requirements for powder-filled Q equipment that has been opened for repair, and where the container is permanently sealed and repair is not permitted by the manufacturer, it shall be clearly stated. So they're beating a dead horse, a lack of better saying, that you shall have these marking requirements if they're permanently sealed or factory sealed. Permanently cannot be repaired. Factory, only repair as the manufacturer says. So don't go opening an EXQ piece of equipment thinking you know what you're doing. If it's permanently sealed, you cannot. And if it's factory sealed, you better read the certificate and the IOMs first. Now, here's a question. What order must you follow with EX documentation when designing, when inspecting, when installing? So IOMs, installation, operation, and maintenance manuals. The certificate is the IEC X certificate. And the standard is the standard we are talking about, or any of the other ones in the series of standards. So order of precedence, meaning which one is the most important document that you must follow, followed by the next, followed by the next. And is there another consideration? So I'll give it another 30 seconds because we really want to get everybody's opinion on this one. Because few seem to be taught this. (63% voted. I would like to get up to 75. Some people are removing their votes. It's okay. Everything is anonymous. Okay. Let's share that. So the second answer, certainly you do not follow the standards first. So anybody who says that IP54 is all that's needed for a piece of equipment and you don't need an IP washer, well, you don't follow the standard. That's the minimum. That's the last document to follow. The actual order of precedence that you follow is you do as the certificate says, then the manufacturer's IOMs, then the standard, and the client specification shall not invalidate any of those EX documents. So if we take a look at this on the screen, one second. So, order of precedence of EX documents. To verify and validate, one shall always refer to the documentation in this order. You always refer to the certificate, its conditions of use, limitations, and the annex. Then you refer to the manufacturer's IOMs, installation, operations, and maintenance manuals. Every standard tells you to do as the manufacturer's IOMs tell you to do. But the specification, the certification is the number one document. Number 3 is the standard. Now, client specifications usually, generally, go above and beyond these 3 requirements above, but they shall not invalidate any order of precedence of those EX documents. Now, if there is conflict between any of those 3 sets of documents, you refer to the highest or the next higher number on the order of precedence of EX documents. I have done inspections where a piece of equipment did not meet the standard, but it was approved as per the certificate and the manufacturer's IOMs. We've had other ones where the manufacturer's IOMs were incorrect. Their installation procedures were unsafe and incorrect. If it was incorrect as per the standard, but we did not have a leg to stand on. But when you referred to the certificate, then we proved the manufacturer had a QMS, Quality Management Systems, issue. They did not produce documentation as per required in the certificate. So, certificate, IOMs, and standard. The client and users specifications generally will go above and beyond. If not, they shall not invalidate any of these three. If any of these are in conflict, refer to the highest or higher number. So, we want to thank you for attending our presentation. EXQ is one of the smaller standards. We're now opening it up to detailed discussions. If you have any questions, please ask. I'll go back to some of the EXQ devices for people to have a look at. This, as I said, this is one of the shorter ones. The most important thing is to be able to visually see what is wrong with the EXQ device. Melting, discoloration, signs that it looks like there's a problem, or using a multimeter or Megger, insulation resistance tester, and finding that there's something internally wrong, because you're not going to be able to open it yourself. Great presentation. Thank you. Thank you very much. If you have any detailed questions, we'll leave it up open for 2 minutes for, if no questions come in 2 minutes, then we will end the presentation. But we will answer all questions. If you have questions about the order of precedence or the IECEx website, or how to use an EX data plate and the certificate to find the relevant information, if you have a choice between the ATEX certificate and the IECEx certificate, always choose the IECEx certificate and also refer to the ATEX. The IECEx certificates is on an online database that is constantly maintained. The ATEX certificates are difficult pieces of documentation to find. Give another 30 seconds. It's okay if there's no questions on this one. It is a lesser used, lesser understood. Like we said, the inspections are more visually, they're detailed inspections because EXQ is usually inside of other pieces of equipment. Even for this device, you can inspect it, but it's your detailed inspection is a visual inspection because you're not meant to open it. In the bottom right-hand corner here, that could be a lanyard, or that could be a breathing point. Spot for a lanyard or breathing point. So once again, the significance of this information, the date of manufacture indicates, well, which issue of the certificate you refer to. The IECEx certificate is the easiest bit of information. Just put that in the IECEx website and it comes up. Then you get details of past certificates, what changes have taken place, conditions of use, limitations, even they have the manufacturer's IOM sometimes embedded within the annex. So if you're ever in doubt, refer to the certificate and you compare the model number on these to figure out which line this is, and you make sure that the marking is exactly correct. And then you go down in the conditions of use and make sure that it is correct. Why is EXQ not often used or selected type of EX protection? Well, it has those limitations of 1,000 volts, 1,000 watts, and 16 amps, all that or below. So it's more meant for inside of other pieces of equipment, such as fluorescent lights. Nearly every fluorescent light that I have worked on, that is EX, has EXQ or M components inside. So EXQ, this handheld operated one, their new cameras and smartphones are now different protection techniques instead of EXQ. Obviously, EXQ makes for bulkier materials, and you have to make sure that they're permanently sealed. You know, since you're not allowed opening it yourself, so the manufacturing of it would seem to be more of a difficulty. So it is good for internal components. If you have an EXE device, you cannot have any arcing, sparking, or heat producing equipment inside. But if you have an EXQ transformer or an EXM capacitor or Q capacitor, that's okay. So within a fluorescent light, all terminals will be EXE, but you're not allowed arcing, sparking, heat producing equipment. So that's why you have the Q and M's and D's inside. Please send them to info@index.ae, ind-ex.ae. If you have any interesting pictures or videos that you would like us to expand on, to comment on, to do a presentation on, and you're not some industry-wide issue you know of, or an issue that you experience every single day and are unsure of what to do, we are here to help. Thank you very much for attending, and we hope to see you next week. Have a good day, good afternoon, and good evening.